All right, solving an algebraic equation. Here we go. The first thing I'm going to do when I look at this is see that I do have an equal side. So there's a left-hand side of this equation and there's a right-hand side. I'm actually going to draw a little picture of a triangle, and that's going to kind of be a balance. You know how a balance has a left side and a right side, and there's usually kind of a teeter-totter piece triangle where the sides can go up or down. So that's going to be my triangle part of the balance. And I'm actually going to picture all of this. See, does that kind of look like a bucket? I'm not an artist, but there's one bucket, and here's another bucket. And right now, the weight or the value of both of these buckets is equal. The balance is balanced. Now, the key to solving for x is that we need to keep it balanced. We don't want it to get unbalanced where the right side is greater than the left, or where the left side is greater than the right. We don't want any of these inequalities. We want them to be equal. So the very first step I'm going to do is to simplify each side if possible. So I'm going to go ahead and look at this left-hand bucket first. And I'm going to notice that we've got a -4 here. We're a -4 and another -7. Those are both constant terms. They are like terms that I can combine. -4 and a -7 is a -11. So I'm going to write that here. I also see a 2x plus another x, so that must mean I have 3 x's altogether. So I've simplified this bucket. All I've really done is kind of rearrange. I've put the 2 x's and the other x right next to each other. And I've put the -4 and the -7 right next to each other and grouped it as -11. So I've rearranged this bucket, but I have not changed the value. So it's okay that I'm doing something here, and I might not be doing the same thing on the right, but I'm not being unbalanced because I'm not actually changing this side. I'm simplifying. Now I'm going to do the same thing. I'm going to simplify the right-hand side. Ooh, right away I see some multiplication. This -2 is being multiplied by a group, so I'm going to be careful. I'm going to leave the 3 and the 4 the same, and I'm going to deal with this issue that there's some distributing that needs to happen. So what I'm going to do is view this, I'm going to view this as a plus a -2 times this. And I'm going to distribute the -2 to both the x and the 4. -2 times x is -2x. -2 times 4 is -8. So I dealt with this stuff right in here, but I left the 3 and the 4 the same. Some students will want to do this all in one step, but it's a lot easier to make mistakes that way. These are still equal and balanced because I haven't really changed the value of either side. I've just kind of rearranged them. Now for my next step, I'm going to use a different color. In this step, I'm going to further simplify the right-hand side. I have a constant of a +3 and a constant of a -8. So this time the constants are squigglies, and before they were underlines. It doesn't matter. I'm just focusing on this side. These are like terms, so I'm giving them a like underline. So 3 minus 8 is -5. Now looking at my variable, oh, look, I made a mistake, kind of. I have another constant here. Oftentimes we have 2 constants and 2 variables, so this time we actually have 3 constants. So I'm going to also give this the same type of marking underneath as the other constants. And I actually have, that was a -5 plus 4 more, so I actually only have a -1 now. Very nice. And then my -2x's, there's nothing to combine those with, so I'm just going to keep them the same. And of course on the left I still have 3x minus 11. That hasn't changed anymore. Now I've simplified both sides. I cannot combine the terms anymore. There's no more distributing that needs to be done, so I'm done with that step. The next step is to get all the x's on the same side. So I could move these x's over here, or I could move these x's over here. Since these are -2 x's, I'm going to decide to move those actually. I'm going to move them over to this side. Either way would work, though. I want to note that. Either way would work. I'm going to add 2x to this side because I want to get rid of the -2x. But now I'm changing this side. So I also need to change the left side in exactly the same way. And remember, with the balance, if you change both sides in the same way, it still stays balanced. So after I make this change, it still is going to be balanced. Notice I wrote this right underneath a negative 2x. So negative 2x plus 2x is just 0. I'm going to kind of cancel those out. Those go to 0, and I just have my negative 1. Or you could think of it as being negative 1 plus 0, but that's just equal to negative 1. Don't even need to write it. On the right-hand side, I already had 3 x's. Now I'm adding 2 more x's, so now I have 5 x's altogether. You see how I didn't write the 2 plus 2x underneath the 11, the negative 11, because that's a constant term, and this is a variable term, so I've lined up my variable terms here. 3 x's plus 2 more x's is 5 x's altogether, and I still have that negative 11. I can't forget to write that there. So now I have a new equation that's a little more simpler than the one above it, right? This it is a little more simpler, the black line compared to the blue line. Now all the x's are on the same side. Now I want to get x by itself. I want to isolate x. I'm going to scoot this up. Right now there's this constant term associated with the x, so I want to get all these constants onto the other side. Right now it's a negative 11, so I want to add 11. I want to use the fact that minus 11 and plus 11 are inverses of each other. So if I add 11 to this side, this is going to go to 0, and I'm only going to be left with those 5 x's. That's nice. X is more isolated. But I changed the side of the equation. I added 11. So I also must change the other side of the equation by adding 11. And when I do that, I get a positive 10. Since I did the same thing to both sides, my equation is still balanced. And now I'm getting really close to the end. At this step here, if 5x is 10, a lot of people will be able to recognize, oh, then I know what x must be. I know it must be 2, because 5 times 2 is 10. But we're going to do it the slightly longer way. We're going to realize that we want x by itself, and right now x is being multiplied by 5. I'm going to put a little multiplication dot in there. That's what's happening. So if x is being multiplied by 5, I want to get rid of that coefficient of 5. So I'm going to divide by 5. What will happen then is that x times 5 divided by 5 is just x. So now x is completely isolated. Yay! However, I change the side by dividing it by 5, so I also must divide the right-hand side by 5 as well. Now I've changed both sides in the same way, so it's still balanced. And 10 divided by 5 is 2. Yay! X is completely isolated all by itself, and 2 is on the other side, so x must be 2. If x was to suddenly boop change into a 2, then this equation would be true. 2 is 2. So x is 2. That's my final answer. Now, it's always a wise idea to check. So I'm going to box this as my final answer. X equals 2, or I can write it over here. X equals 2. X is 2. But I want to check. So I'm going to go back to my original equation way up here. And since I'm using a whiteboard, it's pretty handy. Every place in my original equation where I saw an x, I'm going to replace it with 2. This is how I check my work. Where's x over here? There's an x. 2. And I'm going to do a little work above to evaluate. 2 times 2 is 8. Minus 4 times 2 is 8, so we're going to minus 8. You can think of this as a negative 4 times 2 is a negative 8, or you can think of this as minus and 4. Actually, excuse me, I'm doing this wrong, aren't I? This is not times, this is addition. Let me back up. This is adding, we're not multiplying. We all make mistakes, right? It's all right. So 2 times 2 is 8, but we're doing a minus 4 and a plus 2 and a minus 7. Okay, so 8 minus 4 is 4, plus 2 more is 6, minus 7 is negative 1. You can do that slower if you'd like to, if you want to pause the video. Now on this side, I have 3 plus negative 2 times 2 plus 4. That's 6. And negative 2 times 6 is negative 12. But I'm going to keep the 3 from before in front. This 3 stays there, and this plus 4 stays there. So really what I have in the end is 3 minus 12, which is negative 8, plus 4, which is negative 4. So I end up getting negative 1 is negative 4, which is not true. So I made a mistake somewhere. Maybe you've already caught my mistake. Let me evaluate my answer, which I think is 2. Let me evaluate it in here. 3 times 2 is 6. 6 minus 11 is negative 5. So on my left-hand side, I've got negative 5. And on the right, let me plug in 2. This would be a minus 4. So I'd get 3 minus 4, which is negative 1, minus 8 more, which is negative 9, plus 4, which is negative 5. So actually, when I plug it in here, I get a true statement. I get negative 5 equals negative 5. So that's a true statement there. So yay, that means my answer of x is 2 that I plugged in is true. But I need to catch my mistake up here. What happened? I think I really should have multiplied. Unfortunately, since I'm using a whiteboard and I erased, it was a little hard to tell. But I think this might have been minus 4. Let's see. This should have worked out. Ugh, I caught my error. Silly me. 2 times 2 is not 8. Let's do this again. So when I ended up getting something that didn't work up here, that either means that my original answer of x is 2 is wrong, or it means that I made a mistake when I tried to check to see if it was right. So on my check, I made an error. So let's check again correctly. 2 times 2 is 4. Minus 4 plus 2 minus 7. 4 minus 4 is 0. I could just cross that out. That goes away. And 2 minus 7 is negative 5. So I end up getting negative 5 on the left. And on the right, I plugged this in correctly, I believe. So I got 3 plus, I'll do these first. 3 plus 4 is 7. 7 minus 12 is also negative 5. So I get negative 5 is equal to negative 5, and indeed it is, just like I got it here. So that means that my answer of x equals 2 is true. I can put a check mark next to it, kind of saying that I checked it, maybe. And that is that. I apologize for my confusion on the checking of my work. However, I'm a little bit glad I caught that on video because it's good. Students may very well experience the same thing that I just did, and it's actually really valuable to go through that exercise. So again, if your answer of x equals 2, when you plug it back in, produces something that is not equal, then two things might be the case. Either your answer is wrong, or when you plugged it in to check and evaluate to see if it was true, you made a mistake in that part. And that was the case for me. All right, thanks for doing math with me.